This is example 11, notes 15, a three-variable system of equations. So our first step is to decide which variable to eliminate first. And if we look, the first equation here already has z eliminated. It just has x and y. So the easiest thing to do would be to eliminate z between the bottom two equations. So to do that, we have 4z in the middle equation, and then we have negative 2z in the final equation. So let's multiply that bottom equation by 2, and we'll leave the top equation exactly as it is. So x minus 3y plus 4z equals negative 29. And then equation 3, we're going to multiply by 2 so that we can get opposite coefficients for the z. Okay, that would be 10x plus 4y minus 4z equals 6. Okay, add those equations together. That would be 11x plus y. Z's are eliminated, equals negative 23. So there's one equation involving x and y, and then here's another equation involving x and y. So one interesting thing about this first equation 1 is that if you look at all the numbers, they're all multiples of 4. So one little trick that we could do is divide every coefficient in this problem by 4, just to get smaller numbers. That would give us the equation 3x plus y equals 1. We didn't have to do that, but that just makes the numbers a little smaller. So now if we look at our two equations and two variables with x and y, we want to do elimination with those two equations. So one thing we could do is multiply this equation by negative 1. That would be negative 3x minus y equals negative 1. And then leave this second equation exactly as it is, 11x plus y equals negative 23. Now we have opposite coefficients for the y's, so add the x's together and we get 8x. Y's are eliminated, equals negative 24. Divide both sides by 8, and x is negative 3. Okay, we're going to use back substitution to get the other two variables, so substitute x equals 3 back into this equation. That would be 11 times negative 3 plus y equals negative 23. And as we're solving for y, we'll get that y is equal to 10. Okay, now substitute both this x and y value into one of the original equations with z. Maybe we'll just choose the last equation. 5x plus 2y minus 2z equals 3. Plugging in y equals 10 and x equals negative 3. And then keep solving. Negative 2z equals negative 2. Divide by negative 2 to get z equals 1. So our solution is x is negative 3, y is 10, z is 1.